Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome to Hasib Electronics. Friends, in this series of videos for Inverter IGBT welding machine, today is the lastest video of this series. In this video we are going to discuss control card, the control circuit card, control board. It is here. It is universal. It comes in a standalone piece and it is as a replaceable part. Why I am discussing at the end? Because to know its function we need to know some other parameters before discussing this one, which we earlier discussed in our videos. The temperature sensor. This device is used to sense the temperature of IGBT heatsink to protect it from overheat damage, because it is high current device. IGBT, insulated gate bijunction transistors, it is used to detect the heatsink temperature. The second thing, in our discussion of this IGBT driver module, power module, I discussed filter, inductor. It is actually a peak current detector. In our last video, if you remember, I discussed that here all current flows from this inductor. So basically it is not an inductor, it's one side coil, that is mainline coil, that is just only one jumper, but in the same core there is a winding that transduces the amount of flowing current in the IGBT power section. If there is any short circuit, if there is any overcurrent condition, this peak detector will send signal to the control board. The control board takes power 15 volt and 5 volt, sometimes 15 volt, sometimes 15 and 5 volt from this power transformer, low voltage power supply. This supply provides biasing voltage, operating voltage to this circuit card. There is input for current probe, current sensor. This temperature sensor is connected here at this point. This is an output current sensing component. It is 180 ampere shunt resistor. It have resistance in milliohms. So the dropped voltage, because high current flows to the output side, it is center taped winding. If we have not center taped winding, single winding, that time we have this transducer. This is current probe. The thick wire that is used to produce the current in the output, the thin wire, the small diameter wire, that is current sensor probe. It is around on the coil, so it will produce the relative voltage. So either it is current transducer or it is this shunt resistor. It will apply voltage, the dropped voltage, to this output connector. This circuit is part of short circuit detection and overcurrent measurement, and the current measurement in the output side. And finally it will produce us frequency 47 kilohertz, 50 kilohertz, 60, 65. It depends upon the designer how he has designed the machine. Before starting the discussion on the deep circuit, let's give a look on this diagram. This is block diagram for control loop, how the control card is working. This is functional block diagram. Has power switches, half bridge or symmetrical bridge, anything, IGBTs, MOSFETs, anything is connected here. It will take PWM pulse width modulator output, and it will drive the high voltage, and it will cause to flow the current in the primary. The same as I was discussing, the current transducer, this component, the current is flowing from that component. It is connected in negative line, so all the current will flow from this inductor, from this current transformer, this peak detector. So it will detect the peaks. How much is the current flowing in the primary? It will detect the peak current, and it will give to the peak detect circuit inside the board. In that output side, rectifier side, if it is single winding, then it is using single diode, 1 or 2 or 3 diode package. If it is double center taped winding, then one rectifier is here and the second on the second end of secondary, and it will connect it to the same point and we will take positive output. In this case, single winding, we will use a coil. As I discussed that in the output there is a coil and there is a transducer. It will detect the flowing current in the output side. How much current is flowing in the load, in the electrode, it will monitor the current and it will detect what is the value of the output current. So here we have two things: current flowing in the primary, current flowing in the secondary. If there is no load current and the current is flowing, heavy current is flowing in the primary, that means there is a short circuit. If there is no good combination, there is a big difference in the primary current and load current, that means there is short circuit and heavy current is flowing in the transformer windings due to any short circuit, due to IGBTs, due to output rectifier short circuit, anything is damaged, misbehaving. That time a difference between these two inputs will occur and it will calculate at this summing point. The both currents will calculate it, then the result will set to another summing point. That is current reference. What is current reference? How much current we need from this machine. Suppose it is 200 ampere. This machine can provide 200 ampere and we need just only 100 ampere. We will set value from here, from this potentiometer, that is a panel mounted potentiometer and its related network, some other components that are included with its combination. At this point, this will calculate how much is the difference, how much current we need and what is the value of the current in the output area. Why we need 100 ampere and there is no current, then it will increase the finer error amplifier to control the PWM to produce current at 100 ampere. If we require 100 ampere and here is 70 ampere, the voltage difference, this summing is in form of voltage, so it will calculate 100 ampere minus 70 ampere, 30 ampere, and it will change the biasing for this error amplifier in PWM modulator to increase its duty cycle to produce the voltage, to produce the current at 100 ampere. Here we have just only welding rod. The welding rod, actually we are making short circuit in the two terminals to take more current. When it is short circuit, then it will draw the maximum current in the secondary. To control the current, actually what we are doing, we are limiting the capability of this transformer. If we will set the switching rate at full duty cycle, that means this transformer can provide us 200 ampere and the load will take 200 ampere. If we set the duty cycle from this point, the switching time period at 100 ampere, the duty cycle we can say, for example, 25%. At 25% it will give 100 ampere. At 50% it will give 200 ampere. Actually we are adjusting the duty cycle of this IC, this pulse width. So it is total phenomena and there are some more safeties. Let's discuss. Basically this circuit is SG3525 IC. Most of the time this circuit card, it not exactly for the machine which we are using in our videos, but as I discussed, this card is universal card. It can be modified, it can be used in any machine with pin assignment, to matching pin for pin, and by adjusting the parameters we can use in any machine. So this board is for 65 kilohertz. Our last machine was 47 kilohertz. So here I will give concept, how is the working concept of this card. So this is SG3525 IC as we know, ST3525. Pin number 15 is VCC. Pin number 12 is connected to ground. VCC voltage are coming from low voltage power supply. When we apply voltage, it will provide us tangent reference. This reference is used to make biasing to use as a standalone component, but now we are using it in combination with other circuits. So that time we are not using this reference, it will generate another reference for biasing the components. There is inverting input and non-inverting input. Inverting input is connected to compensation pin. This is used when we control this IC by feedback. This time it is not voltage mod. When we use it to control in voltage mod, that time we control the voltage feedback from optocoupler to pin number 1. This time it is using as a current mod. So to use current mode, non-inverting input is controlled remotely by something else. Sync is not used, oscillator is not used because it is output, and sync is used to integrate with other components. In these cards we need RT, CT and discharge resistor. Timing capacitor, it is 1 nanofarad. Timing resistor 10 kilo, and this is dead time control. Actually these two components are used to set the frequency. In this combination 10 kilo and 1 nano, it is giving 65 kilohertz. If the value of these components will change, the frequency will change. If the resistance will increase, so the charging time of this capacitor will decrease. When it will decrease, the frequency will decrease. Actually we are going to charge and discharge level of this IC. Here is dead time control, dead time between two channels. So soft start pin, this capacitor is used to provide a soft start. This will provide an option to start linearly this IC. Then we have a shutdown pin. This shutdown pin, this pin is used when this pin is connected and it is low. That time the IC will shut down. We can say it is remote on off. Then there is a second option, pin number 8, that is soft start. If it is pulled down to ground level, at that time this IC also goes in shutdown condition. We have two shutdowns. This transistor, when it will activate, it will also shut down, means the PWM pulse width modulator output will discontinue. This IC will stop functioning. So this IC will go in off state. It will stop its oscillation, so our all circuit will stop functioning. So collector voltage 5 volt are applied. This IC can take the same 15 volt as a switching or 5 volt as a switching in the output stage. So our output collector to output A, it is used in output transistor switching. It can also, in some circuit card, it is connected to VCC. Yeah, we can say 15 and 13 number pin are connected to each other in some circuit cards. In some circuit cards it is using a separate VC collector voltage. Any circuit which you are using in any machine, we have to check the voltage at 15 and 13 number pin. If we have voltage at 15 and 13, that means if the same voltage, that means 15 volt are connected. Then we have pin number 11, that is output, and pin number 14, that is output A and B. Some circuit using transformer, using this signal transformer. In that case, two lines are going to this transformer. If some circuit is IC based, that time only one output will be used, and half bridge driver IC will take this signal and split it split this one line into two lines, but in our case we are using transformer, so the output is from pin number 14 and pin number 11. In this case we have output transistor, or we have output MOSFETs that will drive the transformer. So let's move to its control circuit. This is oscillator section, and it is fine adjustment for maximum duty cycle. So these two resistors, this resistor and this resistor, actually it is biasing resistor to set the maximum duty cycle, to set the maximum amount of current. This is the basic computer of this board. What is that? Here is TSM102. In some boards there are LM258, 358, LM724, LM741, OP4, OP05, TSM102. This is dual comparator, dual operational amplifier, and one reference regulator. As I discussed, this reference regulator is not used, so it is using this reference regulator. As I was discussing, it have internal reference regulator like TL431. It is adjustable Zener reference, so it will give us output at pin number 9, and then the same as voltage reference, it have a reference pin. So reference pin will be adjusted, and it will adjust the floating voltage at cathode output. In operational amplifier we have two inputs, inverting and non-inverting, and one output, and in comparator section we have two inputs, inverting and non-inverting, and we have output. To understand the function of these operational amplifiers, let's look at this circuit first, and then we can go in detail. This symbol is for operational amplifier or comparator. As I discussed, comparator and operational amplifier have approximately same function, slight, very little difference between that. It have inverting and non-inverting. The negative, that is inverting input, and non-inverting input, that is positive signed, and it have output. Comparator or operational amplifier are biased with dual power supplies, positive and negative, positive VCC and negative VCC. Here I adjusted as adjustable by using potentiometers. So I am going to power on this circuit. Now it is powered up. We can see the output voltmeter is giving 0 volt, inverting 0 and non-inverting 0. When the both pins are at same potential, the voltage at the both pins are same, are equal, the output will 0. If any input will increase or decrease, we can say if there is an imbalance between input inverting or non-inverting, the output will change. So I am going to make imbalance between both pins. So I applied 12 millivolt. When I applied 12 millivolt positive at non-inverting input, I got plus 1.2 volt in the output. If the both pins, now I applied positive 12 millivolt at inverting and non-inverting, positive and positive. When the both are equal, the potential difference is 0 between the two pins, the output will 0. And if I will decrease to minus 12 millivolt, the difference is plus 12 minus 12, 24 millivolt. So the gain is 10. So we have 2.4 volt in the output. So if inverting input is difference, have difference minus 12 and plus 12, we will take minus 2.4 volt. So its polarity will define what is the difference, what is the input voltage level in the inputs. So at the final, if there is a potential difference on the input terminals, it will give some output in the output. We applied 15 volt to pin number 9, and like a TL431, we have two resistors, R24 and R26. The same calculation is here for this voltage reference. So we will take a reference output from this point. This reference is applied to inputs, any one input of the comparators, to compare the signal. How? If we see this temperature protection circuit, as I told, there is a temperature sensor, so we applied reference through this voltage divider network to inverting input, and if there is a temperature sense output from temperature sensor, so we will take input at non-inverting input, and if there is an imbalance between these two pins, it will give output. For example, if the temperature is within range, the both pins, reference pin and temperature sense pin, are equal, that means then there is no output. If there is a difference, so it will give some voltage to shutdown pin. For example, we applied reference voltage. Now temperature sensor is giving some other output, and we are taking this voltage, low voltage or something. So when there is a difference between these two pins, it will generate an error signal. Some voltage will be applied to shutdown pin. When this signal will apply to this shutdown pin, that time this IC will go in off state, and this shutdown signal will also come here, and it will also disable the soft start section, so that the IC cannot make restart. The IC goes in off state and it cannot make restart. It is our first protection. We can say it is working in normal condition, then there is no temperature difference. We have these three wires, 1, 2 and 3. These three wires are used for potentiometer installed in the front panel. So these three lines are reached here at this balancing potentiometer to make it fine adjustment. And here is short circuit detection circuit. In some machines this short circuit detection circuit is available. In some machines, in the output section, there is a short circuit detection. What is that? There's optocoupling. If there is a short circuit in the output end, this will activate and it will provide pulse here. Most of the Chinese machines does not have this short circuit protection, so we can skip it. If it is available, the circuit was in this condition. Using this potentiometer, we can set welding current set. This is fine-tuned. The one potentiometer is panel potentiometer, the second potentiometer is inside to adjust the maximum level of the current. This is maximum setting. Then there is short circuit detection setup. If we connect this 200 ampere and we have to set slightly above than 200 ampere, so that above 200 ampere it will provide that there is short circuit. This is setting. If it does not have short circuit detection circuit, that time we have just this potentiometer, and in that case we have this sampling circuit. It will give output to this non-inverting input here. The same, here is reference voltage at inverting input. If there is a short circuit detection, this short circuit detection will reach here at inverting input. Reference is 14 and short circuit output is here connected here, so it will compare. If the short circuit is occurred, that time it will give output to this point through this pull-up resistor to this circuit, and it will also make a summing value in these voltage. What is the short circuit current, maximum current, and our required current and short circuit current, it will be sampled here and it will fed to non-inverting input at operational amplifier number 3 input. Now we have to, because it is summing point as we discussed in block diagram, so it is TA current, primary transformer current, that is peak current. That pulses are fed to this pin, and at the same time in the output winding from the shunt resistor the current is sensed, and that is connected here. So we have primary current and we have load current. The both currents will calculated here, and the output will provided through 1K resistor to this point. See again, this is our transformer IGBT side, power transformer primary current, and this is the output current. When there is a difference between these two currents, primary current and load current, if there is a big difference, so that means the current is running inside the machine, so it will calculate and it will give a decision to set the pulse width. Now come to this point, this is our required current, and if there is a short circuit, it will compare with required current and with flowing current, with short circuit current. So the final output will come at output number 3 after all calculations, primary current, load current and required current. The final result will come to this non-inverting input of this error amplifier of SG3525. So it will monitor and what is the maximum allowable duty cycle that can be adjusted from this point. So in this way this circuit card will keep working. When this circuit is working in safe limit, at that time we have PWM output. In that case it will generate pulses from pin number 14 and pin number 11 of this IC. We will take output. The output frequency in this Chinese machine, in our last under discussion machine, that was 47 kilohertz, but in this circuit which I am discussing now, it is 65 kilohertz. So this 65 kilohertz, so this circuit card can be modified to 47 kilohertz using only using this resistor and capacitor combination. It can be calculated. These two MOSFETs 4688 1 and 2, these both are used to drive the signal for signal transformer, and these take input of these drivers is through this 100 ohm resistor for one side, and the second resistor is here. This is the other side. This drive for this IC and this drive for this IC. This pin is connected to pin number 14 and this pin is connected to 9, 10, 11. So pin number 11, this IC is SG3525 and here we have LM358. This board takes two things: how much current we need from this terminal, what is the feedback from this point. This point is coming here inside. This point for transformer is connected at this point. The pin from 1 to 3 number pin, and this end of transformer is connected to this pin. So these two pins are output pin of the board. The shunt is connected, the shunt is connected to this operational amplifier, this pin. And how much current we need, it is also connected at this pin. Pin 2 and 3 of this operational amplifier. Operational amplifier will give pin 2 for shunt, pin 3 for input from potentiometer. So it will take input and it will decide, and this SG3525 will generate pulse width modulation and it will drive these MOSFET drivers. These MOSFET drivers will drive the transformer, and we will take the signal in the transformer output, and it will pulse forming network will form the signal to the gate of IGBTs, and IGBT will switch, and we will take this high voltage switching in the transformer, and this transformer will provide AC voltage and the rectifier will rectify. The rectified voltage will applied to the output terminal from this point and this point. So in this way this circuit is working. So I hope so this video is informative for you. If it is informative, and if you have any question, let me know in the comment box. And if this video is informative for you, hit the like button, and if you If you have not subscribed my channel, subscribe it. And if you want to watch my future videos, you can press bell icon button if you want. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.